Okay, so for the radical section, you may be given different types of problems that I want to make sure that you understand what you're supposed to be doing. So this one is asking us to convert each of these radical expressions here into an expression with this single simplified rational exponent. Basically, what they're asking for is exponent notation. So for instance, if something was x squared, well, x squared is using an exponent, but not quite for rational. So, or I'm sorry, for radical. When we have radicals, they take on the look of something like this: x to the 1/5. Okay, so what this is representing is if I were to write this as a radical expression, I would have this number here, which is at the bottom of my fraction. The easiest way to think of this is, where are the roots of trees? Well, they're at the bottom. So the bottom of the fraction is the root of our equation. Our x goes in here, and then this top number would be to the first power. So if we have something written like this, this is an equivalent way to write it. Now, generally speaking, if this number is 1, we do not write that number. So this really would be written like that. Now, let's take this concept and let's look at just a basic square root of x. Okay, now you notice that there's not a number right here. So whenever there's not a number, it's assumed to be 2, the square root of x. So the way we would write this is x to some power that's divided by 2. And remember, if there's not a power here, it's assumed to be 1. So this would be x to the 1/2. All right, let's do just some silly examples. Okay, say I had the heart root of x to the diamond. I'm sorry, let's do a triangle instead of a diamond. So if I wanted to write that, that would be x raised to the, well, this is my root. Root is at the bottom of a tree or the bottom of my fraction. And then this number would go right here. Okay, so we can use symbols, we can use numbers. Maybe I had the third root of x to the 4th power. So that could be written as, oops, I'm just going to write the radical again. Okay, so that could be written as x raised to the, well, the root is 3, so that goes in the bottom of my fraction, and it's raised to the 4th power, or x to the 4/3. Okay, so let's go up here and let's try to figure out how we would write this. Now, remember, since there's not a number here, we always assume that to be 1. So the way they want this written is x raised to the 1/7. Now, to get this to into your exponent place, what you may have to write is this: x, use your little caret key, which is the number 6 on your keyboard, and then you might have to put this in parenthesis to say 1/7. You may have to do this, but what you always want to do is look over here to the right and make sure that this is what you're trying to say, because sometimes students will write like this, and that's exactly how it's going to read it, and it'll come over here and it will look like this. So it looks like it's x times 1/7, okay? And that's not really what we want. We want it raised to a power, okay? So we don't want that. All right, let's try these next two, okay? Well, since there's not a number here, it's assumed to be 1. So this is y raised to the 1/9, okay? And that will be written like this: y to the 1/9. Okay, always make sure that it looks like it's in the exponent place. Okay, and then this one would be z raised to the 1 over what? Well, since there's not a number there, it's assumed to be 2. So it's z raised to the 1/2, or 1 square root of z. It's another way of saying square root of z, or maybe even just square root z. Okay, that's the way this is written. Okay, so if we were trying to type this in, we would just say SQRT. That means square root of z, would write it like that. And that brings us to our next topic. Okay, our next topic is now they want us to convert each of these expressions into a single radical expression. Okay, so they want this. Well, remember that the bottom of the fraction is the root. Okay, so we want this to be written as the fourth root of x. Okay, and with these, you may want to pay attention to exactly how they want these answers written in derivative. Okay, so let's say that I was doing this. I would not necessarily want to put the 1 here. It may or may not accept it because the 1 is assumed. Okay, so I would never write the 1. Okay, now if this had been 3/4, then you would definitely have the 3 right here. So for this one, this is going to be the square root of y. Now notice I did not write a 2 here. Okay, so for this one, remember we want this to be the square root of y, or square root of y. Okay, now for this one, z, and this is the 5th root of z to the first power. Z to the first power is still z, so I'm going to leave it like that. Okay, now for these next problems, you might be asked something like rewrite the following expression so it contains at most one radical term that does not contain any perfect square factors. Okay, that's a whole lot of words to say. They just want you to reduce this root down. Okay, so I'm going to come over here and I want to give us a real quick lesson on how to reduce some of these square roots. Well, whenever we have a square root, say 25, well, most people would be able to say, okay, that's fine. Well, what's the math that's really going on? Okay, so I'm going to write in the 2 because that means it's the square root. Now I'm doing that for a reason. Okay, because I'm going to reduce this 25 to 5 times 5. Now this square root, even though it's implied, what that's saying is I need 2 of the same items to come out as a singular factor. So this comes out as a singular 5. So the square root of 25 is 5. But this is really the math that's going on. All right, let's look at another example of this. Say I want to do the cube root of 8. Well, we could say the cube root of 8 is, well, 8 is 2 times 4, and 4 is 2 times 2. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And I need 3 of identical items to be able to come out. So I take out these 3, they come out as a singular 3. So the cube root of 8 is 3. It's not the cube root of 3. Be careful that you don't leave the root in there. I have a lot of students that want to leave the root. The root goes away because you've done the math. It's like saying 1 plus 2 equals 3. You wouldn't say 3 plus. We've already done the math. So when you do the square root of 36, that answer is 6. It is not the square root of 6. Okay, those aren't equal. You've done the math, so you no longer need the square root. All right, so let's look at a couple other examples. All right, say we want to do the square root of 100. Okay, some of you may be able to do this in your head, some of you may not. Well, 100 is 10 times 10, and 10 is 2 times 5. 2 times 5. So those are all the factors. So let's see, it's 2 times 2 times 5 times 5. Okay, now since we know that this is an implied 2 here, so I can take out these 2, they come out as a singular 2, and I can take out these 2 and it comes out as a singular 5. So we have 5 times 2. The square root, there's nothing left under that, so I don't have to write any numbers. 5 times 2 is 10. There's a times symbol here. So the square root of 100 is also written as 10. All right, so what happens when we have something like this? The square root of 20. Well, that's not a perfect square, so I can't just say, oh, Square root of 20 is 3. Well, it's not. So here's what we can do. Let's see. This is 4 times 5, or 2 times 10. You can reduce it however you want. And 4 is 2 times 2. So square root of 20 becomes 2 times 2 times 5. So make sure these multiply back out to give you 20. 2 times 2 is 4, times 5 is 20. And we're going to take out 2 of the same items, and it's going to come out as a singular 2 here. Now, since I can't remove this 5 because it doesn't have a partner, it can't come out. So the 2 stays on the outside and the 5 stays under the square root. So the square root of 20 can be rewritten as 2 square roots of 5. Okay? All right, let's go back to our example here. 90. Well, let's try to figure out what 90 is. Well, I always try to do the easy thing. 9 times 10. All right, 10 is 2 times 5, and 9 is 3 times 3. So the square root of 90 can be written as 3 times 3 times 2 times 5. Now, what do we have in common that can come out as a pair? Well, the 3's can come out as a singular 3, but can anything else come out? No. So the 3 stays on the outside, and then I have 2 times 5 on the inside, or 10. Okay, so the square root of 90 can be written as 3 square roots of 10. Okay, now let's look at this one. Rewrite the following expression as a fraction with at most one radical term that does not contain any perfect square root factors. All right, I want you to know whenever you have a square root like this, or any radical, you can always break this up like this. Now, sometimes that's going to help you, sometimes it won't. I'll show you a couple examples here. Well, square root of 81 is 9. The square root of 49 is 7. So that would be my answer to this. Another way that you could work this is, say I had 50. Square root of 50 divided by 2. Okay, well, what I could do is I could break up the square root of 50 over the square root of 2, but that doesn't really help me. That just makes it more complicated, okay? Because then I have to try to figure that out. But what I could have done was I could have just gone ahead and done the math inside. So 50 divided by 2 is 25. Now, that's a simple fraction, or I'm sorry, square root to do. Square root of 25 is 5. So several different ways that you can approach problems like these. Just remember that if you have a square root, you can either reduce the fraction first, like I did here, or you can separate them into their own individual roots, square root problems, okay? Now, as you're working through these, please pay attention to your basic square roots, or whether it's a cube root or a fourth root or a fifth root, that you're paying attention to what the root is that they're asking you to solve for, okay? One of the things that you want to be mindful of is when you're reducing any of these types of problems, that you still end up with the same answer. So another way you can practice this and test to make sure that you're doing this correctly is take your calculator, figure out what the square root of 90 is. Figure out what that number is, then do 3 times the square root of 10. See if it works out to be the same number, okay? If it doesn't, you've probably made a mistake somewhere, okay? Just remember, the only way the square root goes away is if everything under the root goes away, okay? And remember, you're only taking out as many like items as you can. You can't take like the 3 and the 2 because those aren't like items. They have to be a like item, okay? Like this. This is 5s. These are 2s. I have 2s and 5s. Another thing that I want to show you really quickly is, remember when we had this problem over here, this square root 81 over 49, where I could break them up this way? If you have a multiplied factor like this 20, Another way I could have written this is I could have said, well, I know that this is 4 times 5. Well, what I could have done is written this as the square root of 4 times the square root of 5, knowing that my square root of 4 is 2 square roots of 5 because I can't reduce the square root of 5. That's another way to do this. Again, everyone thinks a little bit differently, and I want to show you a couple different ways to kind of think through these problems because everybody, again, thinks a little bit differently. I hope that these videos have helped, and hopefully you won't have too many problems with your homework. Let me know if you have any questions, and good luck.